Cool. Okay, let's get started. Quick round of intros, familiar faces, a lot of cool people. Do we want to start with Automata on the back? Oh, you have the mic? Should we throw it?
All right, yeah. Hello, yeah. Thanks, guys. This is Deli from Automata. We've been building actually quite a lot of T infrastructures. Recently, I think multi-prover is a way to actually transition all the rollups to stage 2. It combines the power of T and ZK. Also, we've been working on like attestation layers that helps verify hardware's on chain. So it not only verifies the like TEs, but it also like attestify your devices on chain so that you can have a more like on-chain identity for your devices. It serves like a proxy for your own like humanhood, but it's more like anonymous proxy. So with all these things, I think also regarding the discussion today, happy to be here. We will see how we can contribute in this area more. Yeah.
Hey everyone, I'm Avi. I'm the CEO of NIL Foundation. NIL is building an Ethereum layer 2 based on ZK sharding, but we've been around the ZK space for a while. Some of you may know us for our work with ZKEVM or Proof Market or our proof system placeholder. Excited to talk about the future of ZK.
Hi, I'm Mamy. I'm the technical lead of Lita. Lita is building Valida, which is a compiler plus prover toolchain to build ZKVM. So compared to most except NIL, which has ZKEVM, we use our own custom ISA, which brings a lot of benefits compared to using, say, RISC-V or MIPS.
Hi. Hello, everyone. My name is Yi. I'm co-founder of Scroll. Scroll is a general-purpose ZKEVM layer 2 scaling solution. 2 years ago, I think, when we started building the first like customized bytecode level compatible ZKEVM, and right now it has been on mainnet for 1 year. It's probably the most like with the most well-established ecosystem with Avi and all those kind of like Ethereum ecosystem seamlessly migrate to Scroll. And right now, like our like like liquidity, like among all the ZK is a top one. And so basically, we build the most battle test ZKEVM. And as the technology keeps shaping, like we also looking towards to build the next generation ZKVM to make the whole chain become more powerful, more featureful, and also extend our tech stack to support other chains. And yeah.
Sounds good. Francesco, I'm actually leading Devrel for Consensus. Probably most of the time I'm dedicated to 50% Linea and 50% MetaMask developers. And yeah, I mean, so this panel is all about ZK research and what's beyond ZK rollups, right? This is probably like I want to start a little bit, like maybe this is for like Neil or Scroll. Like, what do you guys think about what's the current landscape of ZK research? Are we there yet? And is it like an healthy landscape? What do you think about that?
Yeah, so I know this panel is ZK beyond rollups, right? That's it. Yeah, rollups beyond ZK. And I think I'm kind of maybe going to be a bit contrarian to the title here because I think that really the best use of ZK today is for rollups, is for scaling blockchains. And I'm very excited about some of the sort of edges and emergent areas of ZK beyond rollups. But I'm a fervent believer that the best use is within the context of scaling blockchains, which is what we do at NIL with ZK sharding. I don't know, Ye, if you have a different opinion.
Yeah, I think I agree in some sense. Like right now, the biggest product market fit is for ZK to kind of serve for a rollup because the core function for ZK, if you think about like what ZK can do, it can compress a massive computation into something very, very small. But actually the prover, like when you're generating the proof, is actually doing way, way, way more work. So it's basically not like effective. If you just want to compute something, you should just compute that. Instead, you shouldn't like, just using ZK because ZK actually bring a larger overhead on the prover. So the real power for ZK is like, how it makes a huge, massive computation verifiable through very, very small client. and make that become really publicly verifiable. And this is what the whole blockchain thesis is about, because the whole blockchain is about how you have decentralized node and doing small work and bring computation on chain. So I do think that's the biggest product market fit. But I do think there's a trend on new applications on ZK identity and TS notary and all ZK coprocessor and all those stuff. I do think there are still some space for those applications to take off, because some consumer facing solving some privacy issues within a larger application at some parts for that. But right now, because the developer experience is it's still not that amazing. You still need to write a lot of stuff manually. So I think one day when we have more established proof network and you can write very easily, use ZK in a very easy way, it will have more adoption, and but it will start from ZK Rollup, and then moving to more efficient, maybe with ASIC, and getting more and more adoption and getting more use case.
You touched on developer experience. How many developers do we have in the room? Okay. What do you think are the current challenges today for devs around ZK deployments and specific developer tooling?
I think in the past year we kind of solved one of the hardest parts of ZK, which was writing circuits, because we have all those ZKVM that were developed, and you can just recompile ref usually into any ISA, LLVM, Valida, RISC-V, MIPS, and I don't know what else. So this is solved. Then I guess we need to make the experience integrated with all the usual tools they use in the EVM, Foundry, etc. And tutorials explaining the concepts, why it's important, the use cases, basically. And I remember that 7 years ago, you had Crypto Zombie that taught everyone how to use the EVM through a game, and we need a Crypto Zombie moment for ZKEVMs, ZKVMs.
Yeah, regarding the developer experience on ZK, I think we'd like to also share a little bit, because we are actually also building applications on top of ZKVM. It's just for attestations, and based on our experience, it's quite straightforward, because we have the logic written in Rust, then we put the Rust gas program inside both maybe 16 SP1 or either RISC-0, R0 VM. It just works, I think. Compared to 1 year ago, at that time we tried one of the ZKVM. It was terrible, because there was some kind of error that we couldn't understand, but now it just worked very smoothly. And in terms of the proving, I think both networks have fairly good proving backend infrastructure. So very quickly you can just get the proving request served. So I think it's kind of amazing to be able to use even within our kind of this kind of TE developer space. Yeah.
Yeah, I'll just add I think I would agree with what everybody said. It's become a lot easier, and I think from a strictly a developer experience, ZK is very usable. I think one of the issues is reasoning about where is it appropriate, right? And to what Yi said here about the overhead, there aren't that many things, at least today, with that overhead that make sense to eat the costs that you would incur from having something verified within some sort of provable environment. So I think as time goes on and we get hardware acceleration and algorithmic optimizations, and that overhead shrinks, we'll have more and more use cases that make sense. But I think really the difficulty today is one of reasoning. Where does it make sense to have ZK? Where is there essentially value in that verifiability that allows me to incur that overhead?
Yeah, this is a good point, right? I actually in the past, I'm trying to only go to developer specific events, and that's why I really appreciate so many developers in the audience. But I'm always hearing T. But you're speaking about integration. The question maybe that's for Automata, for you, Deli. How you kind of integrate T on ZK research, for example?
Yeah.
And maybe just say what's TE in a nutshell for the people that never heard about it.
Yeah. I mean, this is clearly a ZK event. Let me try to explain TE a little bit, but I guess there's experts in the audience as well. So it's essentially like private compute environment that you can use. One of the most prominent example recently is actually Apple. They're using this private cloud compute. Actually, those are just TE machines that are running in their Apple cloud. They're trying to convince people that they're not doing anything wrong there because you can check the devices can verify the code so that your personal device can just offload some of the AI compute to a remote node. Like in terms of the some of the like overlaps, we've seen quite a lot. For example, the work we're doing with Scroll, we're working on multi-prover. We're helping them to just develop the like the TE proof implementation so that it will just re-execute all the like L2 batches in a way that like once goes on chain, you can verify, you can get the proof from both systems. Then you can verify if they're matching or not matching. If they're not matching, you could have maybe a security console to just solve the conflict. So these are quite straightforward collaborations. And also, just like what I said before, we're using ZK for accelerating the attestations. Because originally, attestation wasn't meant for on-chain. We moved it on-chain by just like building in Solidity. It works, but the like attestation cost is really high. Like it costs us like 4 million gas per attestation for some of the TEs. Then we just go to the like ZKVM route. We wrote a small like Rust program, does all the verifications, but then put it in a circuit, and we just need to verify a small like footprint on chain. It worked, and also like bring down the cost a lot. But of course, we will be just providing all this as different routes for attestations. People can still choose, like if they want to like just use a native Solidity version or any of these like ZK accelerated versions. So these are some of the areas like we're actually doing. In the meantime, I'm actually more interested on like some of the new areas, like how private input proving can be done in ZK. I've seen like discussions on like code snarks. People are trying to split the work among different MPC node and try to do the snark proofs there. But I'm more interested on like how TE can help in this case. Maybe a single node can just run a circuit inside, then allows you to just provision the private like data into it without like getting compromised or without like letting the operator know. I would say yes, there's still a lot of overlaps. We are still exploring. We're trying to see how TE can be a kind of another layer of security. In a sense that we're building a more like defense in-depth solutions rather than just trying to replace any other attacks. Yeah.
Yeah, I think I want to add something to this. Like the way I think about TE is like it's always like for cryptographers specifically. Like TE is always like a cheating black box. So basically, like what ZK allow you to do is like you want to prove something, and then you have prover, you generate proof. TE is basically like it's a black box. You put your program, and the black box tell you like it's right, and then you just trust as far as you trust Intel, then it's right. So I think it's always a way for cheating, because you trust this black box. But it's actually, I think it's a really good training wheel for let's say you don't have 1 second prover time, right? Because every time you delegate a program, the prover run for 1 minute, 2 minutes, 1 hour. But TE, you always get a real time result. So before I think ZK get performing enough to be sub-second, you can always use TE to simulate a real-time proving and that environment. And then you just imagine with your program running within TE, and then it's exactly the same as ZK generate proof in time. And also TE provides a really kind of a different property, equivocation, because ZK can prove you something something is valid, but it can't prove to you something doesn't happen. But TE you put the program inside, and then it will tell you that I only run the program. So there are still some kind of privacy and equivocation related feature that TE can provide as really good simulation tools to before certain technology become mature, like MPC, FHE, or all those.
If you're interested to read more about TE, Justin Drake from the Ethereum Foundation proposed a post 2 years ago called Two-Factor Authentication of ZK using SGX that you can read on ETH Research Forum.
That's a good point. And by the way, I'm hearing prover time, you touched a little bit on costs. I think like at the end is a trade-off between a kind of specific like kind of verticals, right? And I want to speak a little bit about what do you think are the trade-off between, I'm hearing ZKEVM, I'm hearing ZKVM, coprocessors, like, and I think also like those trade-offs are also very aligned on the specific use case that you want to implement. But do you want to touch a little bit on those trade-offs and specific use case? And feel free, everybody, this is for everyone.
So trade-offs between like ZK, I wouldn't say it's a fair comparison if it's like ZKVM or ZKEVM, because ZKEVM is more like really specific build, like a circuit, right? For maybe even a particular like ZK rollup. But ZKVM is definitely more general, and coprocessor is more general as well. But I guess, or even you can build a coprocessor on top of the ZKVM if you have some assumptions over there. But sometimes I've seen like even like Brevis is building their own ZK coprocessors for like creating like VIP trading program on DEXs, or even doing like machine learning coprocessors over there. So these are actually more like prominent use cases because like it directly faces like users. Like I've seen people building like us, like we're developers using ZKVM, but the use case we build is more like just to other like projects as well. It's more like 2B instead of 2C. So I would say there might be slight difference in terms of like the use case or different fronts like that we're building for different customers. Yeah.
Well, for me, the trade-off between ZKVM and ZKEVM are pretty easy. ZKEVM are being replaced by ZKVMs, plus precompiled syscalls, or whatever everyone calls it. Like Scroll had a ZKEVM that was co-developed with Firm Foundation and Taiko, and they are replacing it with a ZKVM because developer time is very costly, and writing circuits, if you want to be type 1, type 2 EVM, which both Polygon, Scroll wants to do, you need to keep up with the next evolution of Ethereum. And for example, the next one will maybe bring vertical trees, will bring BLS cryptography, and this is just hell to audit. And even the layer 1 will finish maybe 1 month just before. And then all the rollups, if I want to be type 1, they need to finish implementing, auditing circuits within that month. Otherwise, they aren't type 1 anymore. So ZKVM are impossible to maintain unless Ethereum gets ossified.
Yeah, well, I mean, I guess I want to point out that even the EF themselves, right, are looking and thinking about departing from the EVM in the context of snarkifying the base layer, right? So I think that trend will continue. But I do want to, in some regard, defend the case for ZKEVMs, right? Which is you want to be EVM compatible. And only until very recently was it possible to be running these clients right within a ZKVM where it's like even feasible. So, yeah, maybe picking up on a little bit of ZKEVM, hate, but there's very clear logic for why you would do that, just a few months ago.
I love the word snarkifying.
Yeah.
That was cool.
It's a good word. It's not my word, but it's a good word.
But yeah, for people. But did you see any like specific use case? For example, you see, okay, this privacy and preserving is specific for ZK processors, or like everybody's kind of like the wave is going in one specific direction, or you see like a clear kind of like winner use case adopting a specific kind of like category?
Well, I mean, if you read Vitalik's latest series of blog posts, in there he even discusses departing entirely from the EVM as the execution sort of runtime for Ethereum and looking at RISC-V or Cairo. Now, that's not like a something set in the roadmap, but I think it's a clear indication of, okay, the EVM has these bottlenecks. There's these ZK sort of optimized runtimes. Why are we continuing to work against the EVM, right, in the ZK context? Why aren't we, adopting these more optimized, performant runtimes? So I think there's a very I mean, I think there's a strong possibility that that's actually where the base layer moves, and if Ethereum moves in that direction, well, where are layer 2s, right?
Just to give a bit even more context on this, I used to be from CoreDev back in 2018, and there was a project called EWASM to remove the EVM, and then it was kind of shelved because it was too complex and too risky. And this changing the EVM execution environment is actually resurrecting those EWASM, but now eRISC-V, I guess, discussion from 6 years ago.
Yeah, I think EVM definitely need to keep EVM, all the kind of backward compatibility stuff. I think the way I think about like why people start talking about ZKVM firstly is because like 2 years ago when it started, like EVM is like impossible, ZKVM is possible. Like ZKVM is impossible and ZKEVM is the only way like you can build a rollup with efficient prover. And right now I think the way I look about ZKVM is that because it's efficient enough, like you can still get extremely low cost for running the prover, and then like the development velocity benefit that bring by the ZKVM is kind of catching up, because if you think about EVM, right, what EVM really care is EVM care about security. And so imagine if you do any kind of like add any new precompile, add any new kind of like opcodes, and you need to develop the whole underneath like ZKEVM to be audited and like wait for a few months. That's really slow for like for the whole thing, because you make changes to both execution, which will influence a lot of client implementation, and also the ZKEVM itself. But if you have a cleaner separation between like, for example, ZKVM, which whatever like execution code you change, you can always use the same backend, and you can make sure like the ZK part is ultra secure. You can use formification, whatever, to make that part extremely secure. And then you keep a very high development velocity, because you can change execution, and then you can be easily aligned with multiple different clients, have a very clean separation on like the client team just worry about the client, the ZK team only worry about like the underlying the fix circuit, instead of like keep changing that in together with what you are changing on the execution side.
Yeah, I like what you said about Avi on the side of on the specific kind of like non-EVM versus EVM. I mean, my only question is, at what point do we care? I mean, I don't know, after all this time of like building and driving developer communities, I don't know how long this game will be a product game. I think it's also about developer adoption. And like even if we're saying, okay, we want to build, a Starkware-based ecosystem, like start to do like Cairo 2.0 workshops to devs. You will actually be impacted and saying, okay, this is the reality. We are working with devs. So it's not only a product game, like it's an ecosystem adoption game, and the ecosystem adoption is starting with developer liking our tooling and the tooling ecosystem we are building around our stack.
Yeah, 100%. I mean, we're building for the EVM, but that is 100% a business decision, not an engineering decision, right? If we, wanted our engineers to be really happy, we would not be working with the EVM, because it is an uphill battle in the context of proving. Yeah.
What do you think developers are caring about, like today?
I think developers, I don't know, I think we should probably ask the crowd what they think. At least from my experience is, you want like the lowest barriers to entry, right? You want it to kind of be like a very fluid onboarding into a new ecosystem. And so, yeah, like EVM compatibility is important. At the same time, I think developers are starting to realize that if you are just an EVM equivalent rollup, you're not really doing anything very interesting, right? And that if you want to see more innovation within the layer 2 ecosystem, especially at the application layer, you need to start going beyond, just these sort of naive EVM, equivalent, single rollup deployments.
Yeah, I think firstly, like getting a like even EVM equivalent rollup like working is already something like it's already achievement. Like especially 1 year ago, like look at how many like really being compatible. Like ZK Rollup is out there and has been battle tested, and also the way I think about that, like for most of the developer, I think Solidity and all those EVM tooling, because the tooling is just like 10 times like ahead like than any other kind of language. Even if you switch to like RISC-V and some other stuff, under the context of blockchain, the tooling is just way better. Like you have like those kind of like toolings, JavaScript toolings for you to kind of easily write your application and safely. So the way I think about that, the involvement might be like you start with EVM, but you gradually add more and more precompiles to kind of enable like account abstraction or certain features that really like passkey and all those kind of precompile to enable a new development feature. And then like you evolve into a stage where it's like still compatible with EVM, but if someone want to like write more efficient code, they can port certain library for certain execution, or they can just directly use ZK coprocessor for certain computation instead of like breaking the compatibility. And also because if EVM is really committed to kind of sacrificing itself into a ZK EVM and having a lot of like distraction from this path might not be like really kind of super aligned with this roadmap, because eventually if EVM is going to adopt this and like you are kind of like the difference will be larger and larger, you want to kind of trying to reduce the difference instead of like making the gap become larger and larger.
Makes sense. I think we can almost take a couple of questions from the audience. I just want to say we spoke about T, we spoke about ZKVM, ZKVM, EVM. Like, what are the things that you're looking forward coming next? Like, there are kind of like, not in 3 years, like 6 months next.
Right. I think with all these tags, I'm actually more interested in AI nowadays. We've seen a lot of AI agents being built.
AI agent, I knew it was coming.
I'm trying to see how we can really build it out, even like use all of the technologies here. But it seems that like some of the like big enterprise, they have made the decision they're using TE for now because it's probably the most practical ways. And we've even tried like previously with H100 GPU because like if you can have a TE measurement in terms of the entire environment, you do have certain like guarantee to use that because you're not touching their data, you're not touching the model as well, or even you can present the proof that this is really the like maybe the like 405B model instead of like smaller like model that I'm selling. But I'm more looking forward to like a stronger proofs in the future. Like if we can really make use of ZKVM or even like some of the like hardwares that use this kind of abstractions for us to build more trustworthy AI applications, AI agents. I mean, compared to other applications, this is actually the most interesting and exciting ones. Yeah.
So I think AI is a perfect fit because you have all those scandals about copyright, and technically with ZK you can prove that you train a model on some specific data, a data set that you provided, and that's good because you avoid lawyers and inquiries if you suspect you stole some artist's pictures or something. But ZKML was really big at DevConnect a year ago, and I haven't seen news of ZKML in the past year. And I have a T-shirt of Kaggle, which is like a big AI data science competition website. So I'm very interested in this. I feel let down.
That's a good point. Also, what are the things that you were expected to see more and they are not here yet, right? I think that's a good point.
I think Ezekiel is a sponsor of this event. There is also Modulus Lab. They've been so Ezekiel has a really good tooling integrated with Python, with GPUs, etc. Modulus Lab had this GKR prover with 1000x acceleration for ZKML, and I think it was early September. Google was mentioning ZK in an internal meeting, but only announcement, no product yet.
Yeah, I would potentially want to see more like, it's a boring answer, not AI related. It's like our upcoming like upgrade for supporting multi-prover and ZKVM to enable like a a lot of like new features, new precompilers coming to Scroll and the SDK, which allow you to kind of launch your ZK chain in 5 minutes. So, and also I'm expecting a lot of like the ZK email, like TS Notary, all those stuff to be integrated into certain applications, and like how you use ZK to prove like social logging without third-party dependency, and that's really going to like application level and holistically bring a better UX to bring like a lot of new user on chain, and being very practical, and like what's the influence for using ZK in a product that can actually benefit the user instead of like just having some really fancy like I want to prove this because it's like it's cool. It's like something more practical, something more start with something small and replace certain components and then bring real UX benefit.
Yeah, I'm excited for the ZK TLS stuff. I think bringing like Web 2 infrastructure on chain, that's exciting. But I'm going to come back to like my opening comment, which is I think the best case in product market fit for ZK today is scaling blockchains, and it will be core to building the most scalable blockchains in the world, hands down, bar none. That's where we're kind of putting our bets and spending our time with ZK sharding. I think that's where a lot of the industry is moving, and we may even see folks like Solana rethinking their strategy in the coming years.
Sounds good. Any questions, guys? I think we're almost on time.
Hey, hi, I'm Rahul, and this is a question specifically for Ye and probably Avi. So in the ecosystem right now, the play is with the zkSync, Polygon, Optimism having a somewhat stable L2 running. And then they have come up with that, hey, my chain works, so why don't we create instances of that and create an interop between them? So what do you think of that? And does Scroll or Nil see themselves going in that direction?
Yeah, that's a great question. I do think like one of the biggest like opportunity for ZK is kind of fast finality, and fast finality only matter if you want to do cross-chain communication. And so basically, I think the biggest use case for ZK like to enable more trustless communication. But I do think like we have our own like interop solution like for how different like Scroll SDK chains can talk with each other. But because like if you really want to unlock a lot of like UX benefits, and so right now our solution is like we want to use TE to simulate a real-time proving, to make sure like, because if you imagine like you want to two chain talk with each other, right? You need to wait for one chain generate proof and bridge, and then like bridge in, right? So basically proof generation takes like 20 minutes, 15 minutes, and like it's a really bad interop experience. So let's say like you have like TE and like you use that to simulate real-time proving, because basically like you can like send a message, and initially and the other chain can opt into this and like trust this message and directly enable the seamless interop. And then later when you really have like 12-second proving, you just replace TE with a kind of ZK solution to enable a more trustless kind of like interop solution. That's basically the way how I see this space is going. But another like maybe like not like so popular take is that I don't think like interop is the most crucial thing we really need to solve right now for multi-chain. I think multi-chain has like 1,000 different other problems. Firstly, I think it's really double down like your own chain, making that usable and making that like working in a very kind of stable way, and then like you later like I think as more chains start coming and like you actually enable this kind of interop solution, because even with ZK you can't have synchronous compatibility. It's very hard unless you share everything, and then this almost become like a single chain stuff. So it's like I do think there's a lot of other features that ZK can bring to the multi-chain future.
Yeah, I mean, I would, my view, and I think where a lot of the industry is moving, is that the end game of blockchain topology is local execution, global synchronization, right? Which is, what Ethereum was so right in so early on, 2015 execution sharding, and then all kinds of layer 2 solutions, which essentially enable these local execution environments, independent state machines to run and then globally synchronize at some later point. And I think this is how you build something like a world computer. There's just no other way for you to do it. You cannot fit all of your processing power for a truly global financial system, not just a single application, but a system on top of a single server. And so I think this is why you see a lot of teams, who originally deployed rollups, now trying to kind of work backwards in building these, unified cluster deployments that look like a sharded network. And that's very core to what we do at NIL, is sort of taking a first principles approach, saying, okay, knowing what we know now, where we want to have these cluster deployments of these sort of very tightly coupled shards or rollups, how might you design a system for that? And that is where we spend our time with ZK sharding.
So Justin Drake had a talk in March at Pragma London about United Chains of Ethereum, which was really exactly about this, this synchronous composability. And if you have real-time proving, well, real-time being within 12 seconds, you can have MetaMask UX work very hard to make the cross-chain transaction. Like Rollups provide fast proof, and then MetaMask work hard to make the UX very nice. And then for users that don't need to breach assets in thousands of rollups to benefit from NFT there, Uniswap somewhere else, flash loans on mainnet, and I don't know what.
Oh, hello, my name is Harsh. I had a question around emulating the EVM inside ZKVM. So at what cost delta does it start making sense to optimize for just just emulating the EVM in a ZKVM? Let's say how much should be a cost delta where you would say that, okay, if proving through a ZKVM is at least this much less expensive than writing the circuits, then it just makes more sense to never write circuits and keep just recompiling in a ZKVM.
I think for us, it's in terms of cost. If you can make, per transaction, average cost is within 0.01 cent or something, and then it's a reasonable cost with for example, less than 20 minutes or 1 hour, proving time. Then I think it's a kind of good trade-off you should make to kind of use this prover and then increase your velocity for, improving our execution.
Also, in terms of ZKEVM costs, you need to think about the cost of developers and the cost of auditing and the wait for auditing, because auditors are booked for the next 6 months at least.
Other question, guys?
Okay, cool. So big round of applause. Thank you so much for your time, and thanks for staying.